morning.
Hello.
Hello, welcome back. I'm Colton King, and with me is Bill Bolte and Emery Baca. We are with MCR Oil Tools, the new standard in pipe recovery technology. We're the three that make up MCR's technical advisor team. How you doing tonight, Emery?
I'm doing pretty good.
Hey, how about you, Bill?
Oh, I'm doing very well. Just been a very busy day and a lot a lot of pipe recovery going on today all over the world. So it's been an exciting day.
Yeah, there is. It seems like the oil field's picking up. Lots of calls coming in. People needing assistance and help getting some pipe out of the ground. That's always good. Things are looking up. The, so kind of our last episode, we talked about what it took to be a pipe recovery specialist, and what is pipe recovery, and kind of went into an explanation on what it is, on being the problem solver out there, and how a pipe specialist has to, in Bill's words, be the fighter pilot and have that can-do attitude. This episode, we thought it's probably the next most important thing to go over, and probably in a lot of instances the very first run or thing that should be suggested, and that's free pointing. I don't think
yeah, that is absolutely true. Yeah, free point, that's some of the most valuable information you can have.
Yeah, I don't think free pointing gets enough credit or enough spotlight on how important it is in pipe recovery, and laying out the whole job off of that single log.
Yeah, if you don't know where you're stuck, how are you going to get free? That's the first thing you need to know. Where are we stuck? And to find out where you're stuck, you use a free point tool, or you take a stretch reading, or or some people, I guess I knew a fella, he said he'd been in the pipe recovery business so long he could think like pipe. And so maybe you get somebody who can think like pipe and they'll tell you where they're stuck. I don't know. But knowing where you're stuck is one of the most important pieces of information you can have.
Yeah, I mean, you can run in the hole and cut pipe and try and back pipe off all you want, but unless you know where it's going to come free, I mean, all you're doing is wasting time and wasting money. Without that run, you're just guessing.
That's
Yep,
exactly
that's
correct.
And I mean,
in 1977, when I first got in this business, one of the things that amazed me was pipe recovery. I met these pipe recovery guys, and they would talk about going in and unscrewing the pipe, thousands of feet in the hole. And one guy said, "Well, yeah, I was on this job, and I asked that company man whether he wanted me to get that pup joint out of the hole or leave it in the hole." And the man just laughed at him and said, "Yeah, bring that pup joint up." And sure enough, he did. The 3-foot pup joint. He brought it up. So that's pretty good. He could, down as deep as they were, he could was able to unscrew a particular 3-foot joint of pipe, and I was very impressed by that. So how in the world did you do that?
Yeah, I mean, pipe recovery and free pointing. I mean, anybody can go out and cut pipe and back pipe, even back pipe off. Once you understand the science behind it. But a true pipe recovery specialist can run a free point tool and watch that balance needle and interpret what that needle is telling him, and explain to the customer or the company man or consultant on location what's going on down there, and help. The free point tool is the paintbrush to the canvas. You're starting to paint the picture once you get that tool in the hole and start stretching some pipe.
Yeah, that's very true. And the the theory behind the free point tool is just basic physics. You know, Hooke's law that says stress is proportional to strain. The more you pull on a pipe, the more it stretches. And we just have a device that goes down and detects when the pipe is being stretched. And if we can detect a little bit of longitudinal movement in the pipe, a little bit of stretch in the pipe, we infer that the pipe is free there. And if we go down deeper and we pull on the pipe and we don't see any movement, we'll say, okay, well then it's stuck. And then we work around and try to find out where we start getting movement.
I mean, what is free pointing, Bill? I mean, maybe you can explain it best. You know, what is free pointing and the whole theory behind it?
Well, the theory behind it is that when you pull on a piece of pipe, it's going to stretch. The more you pull on the pipe, the more it elongates. Within it's called within the region of perfect elasticity. If you pull on the pipe too much, you get into plastic deformation, and then the pipe won't return to its original strength. That's you've exceeded the yield point of it, and when you see yield point on the pipe, that's what they mean. You can, if you pull it past if you stretch it past the yield point, well, the pipe won't return to its original length, and then basically you ruined it. So, but if you stay within that below the yield point, if you stay within that range of tension in the pipe, when you pull on it, the amount that it stretches is proportional to how long it is. And the longer the pipe is, the more it's going to stretch with a certain amount of we'll call it overpull, a certain amount of overpull, and that's the basis of taking a stretch reading. You know, we pull on the pipe and measure how much it stretches, and then looking at the characteristics of the pipe, you know, the diameter and the wall thickness of the pipe, and we can actually calculate the length of the pipe from how much we pulled on it, how much it stretched, and what the cross-sectional area of the pipe was. But then we developed some electronic devices which would measure very small amounts of stretch. So, you know, typically a free point tool would have a strain gauge in the middle of it, and then it would have anchors at either end of the strain gauge, usually about 66 feet apart, about 72 inches apart, and you run in the hole with this device and somehow affix those anchors. There are different ways of anchoring the free point tool on the top and the bottom, and then you stretch the pipe, and the distance between those two anchor points will increase, and it just has to move a tiny amount, just a few thousandths of an inch, and that strain gauge can detect that movement in the pipe. And if you get movement in the pipe, then you say, well, if we pull on the pipe and it moves, it must be free. And if you pull on the pipe and it doesn't move, you say, well, the pipe is stuck. And then we go up and down, and finally we locate the point where it just starts to move, and then based on our experience and the equipment that we have and how it was calibrated, we can come to a conclusion that the pipe is free here, or it's mostly free, or partially free, or mostly stuck, or partially stuck, and
yeah,
that's where we start trying to unscrew it.
Yeah, no, it's it paints the roadmap and draws it out at
Yeah.
what's going on. And I think another tool in free pointing that doesn't get enough credit or enough attention that a lot of people don't think of is a stuck pipe log. Using a sonic stuck pipe log, especially in a clean out or drilling situation, can provide a lot of information that a free point tool might miss. And I don't know, Emery, you got quite a bit of experience with stuck pipe logs and logging tools.
Right.
Why don't you explain kind of how a stuck pipe log works and how kind of break that down?
Okay. Yeah. Yeah. Stuck pipe log, basically, like you said, is a sonic log. It's essentially, it's the same thing as a bond tool. And most people, that's what they do. They run a bond tool. Um, and it works exactly the same way as a bond log works. You're basically looking at the attenuation of the first arrival, the casing arrival, and wherever it's partially sticking, you'll see a reduction in the amplitude, and where it's free, it'll be free. So you basically set it up, just like a bond log. You find free pipe, you set it up there, and you log coming out of the hole looking for that. Where they work extremely well is like you said, is in either unconsolidated sand zones or sand sticking in wells. They complement a free point really well by, the free point's going to tell you where the stuck point is, but it's not going to tell you where how much you have to wash over. And an example was, I remember running one where we were, they were free pointing to see they were going to cut the tubing on top of a packer because they couldn't pull their packer. And so they thought the packer was stuck. Well, the free point hand was out there, and he ended up saying, you're stuck about 3,000 feet above your packer. And they were like, oh, no way. And so he finally convinced them to to holler for me to come out and run this bond log. And I ran the log. And so it basically showed right above the packer, they had about 10 feet of fill, and then it was free all the way up to that mark where he said it was stuck. And then he had about 20 feet of bridge in around where his stuck point was. And so sure enough, they found out it was a water sand up there. And so they were sand stuck, and they only had to wash 20 feet. When he told them 3,000 feet, they were worried they were going to have to, wash 3,000 feet of pipe. And so basically they were able to, back it off. I think he actually backed it off. They ran wash pipe, grabbed onto that pipe, picked it up, and then he backed it off right above the stuck point down at the packer. And then they ran a short piece of wash pipe again and washed it out and got it free. So that's where they work really good with the free point tool, is it lets you know if you're looking at a situation where you're going to have to do a lot of washing.
Yeah, absolutely. Go ahead, Bill.
So the free point tool just gives you the uppermost point where it's stuck. But with this sonic pipe recovery log, you can see every place where there may be sand bridges or some sloughed off shale or something
Right.
in the hole, and it'll tell you all the stuck places. So you get
Right.
a really good idea of how much work you have ahead of you.
Well, and
Right, exactly.
I think an issue a lot of people run into is they'll run a free point and do a free point, and you'll have a bridge maybe 2-3 feet right above a collar. There'll be a pretty good packed off bridge right there that's about the distance they've been stretching it, and you'll go in and free point it, and you'll see stretch all the way down below that point, and you'll go in and cut the pipe, and the pipe will jump, but the weight won't go all the way to neutral, and they'll go to pull it out of the hole, and they're still stuck. And that's where the stuck pipe log comes in handy,
Oh, yeah,
because you're able to
Yep.
go in and find them bridges. Anytime you're doing a clean out or any sort of sloughing situation, anything like that, I think it's very important to run a stuck pipe log with your free point, because it's going to find stuff the free point tool can't. The free point tool's just measure and stretch in a very small area. I mean, the pipe only has to move milli-inches to show stretch in a free reading, versus that sonic stuck pipe log is going to show where it's packed off and where you probably ain't going to be able to get a collar through it. And like in that situation, Emery, that you was just talking about, the oil company or the E&P company was thinking, man, we got 3,000 foot of stuck pipe. We're going to be here for weeks, months washing over, cutting, and a
Yeah.
sonic stuck pipe log reveals, well, we just got this 20-foot section to wash over, and then we're smooth sailing and can go down, and this actually ain't going to take so long. So it's a very valuable piece of the puzzle to run the two tools in conjunction together, one right after another, to really, I think on big complicated pipe recovery jobs, especially on big horizontal cleanouts, drilling rigs that might be experiencing sloughing, you kind of got to run both and put them together to create a theory of what's going on down there.
Right. Right.
Yeah,
And
yeah. Go ahead.
Oh, go ahead, Bill.
No, I was going to say, yes, finding a sand stuck or sand sticking is a difficult interpretation, because you actually get movement. In fact, sometimes you can get full movement of the strain gauge in your free point tool, and your free point tool is saying, well, this is to the extent we can see this is free, completely free. But with using the sonic pipe recovery log, you can clearly see the collar, you can clearly see the tool joint, and you can also see above it where there's a little bit of space, and then there's a sand bridge, and there is your classic sand stuck situation. It shows you that you're free with your free point, but in actuality, you're only getting a little bit of movement that a collar or a tool joint is moving up and down after you work the pipe, you make a little cavity in there where it can move up and down freely, but not very far.
Yeah.
And the sonic pipe recovery log clearly shows that to you. It resolves that ambiguity just very, very quickly.
Yeah. Yeah, I would. One of the things I just thought of, I've never ran one for it because I usually think it's pretty obvious when you're doing your free pointing and stuff, if the area you're kind of stuck at. I would imagine it would also work pretty good if you're like key seated, because your pipe's going to be laying off in that
Yeah.
in that key seat, and you'll see that formation around the pipe in a key seat. So, I mean, it would probably be pretty useful right there too. I've never run one in that situation, but
Yeah.
I imagine you could.
Yeah, I remember a job I was doing. We went in and free pointed it, and was stuck like 10 feet above the packer. Okay, yeah, pretty simple. Go in there, we cut it. They pulled into it, cut it, and the pipe was supposed to drop to about 65,000 for a string weight. And we had pulled up to about 85, 90,000, and we cut it, and it dropped to about 75, 80. It didn't go all the way down, and it was like we lost weight. Okay, great. I was rigging down, getting out of the way, and the rig goes to pull the pipe, and they're still stuck. And they had moved the pipe a couple more feet out of the well, and I was like, well, we cut it. So I rigged back up and went in the hole with a weight bar and a CCL and looked at my cut, and sure enough, there's about a 3-foot gap between the two cut planes. And what the heck's going on? And I rigged back up a free point tool, and we go in the hole, and we find it stuck in a different place. Okay, well,
right.
We go in there, we cut that, and the pipe dropped and fell down hole and smacked back on top of the fish, but the rig was still stuck. And it was like, man, what is going on? So I called for an RCBL to come out there, and I get a 1-11" bond tool out, and I pick it up and I go in the hole, and I found about 3 other places that, to the untrained eye looking at it, it looks just like a, free pipe bond log, but there was about 3 other places right above the collars that the amplitude dip, and the signal coming back had really dropped off, and it was like, man, I think there's stuff going on above these collars. And so we cut at the uppermost one. I talked with the fishing hand and the company man. I said, I think we got a bunch of bridging going on around the collars. And we cut at the uppermost one, and they went in the hole with wash pipe to that first one. And sure enough, they sat and turned on it with wash pipe for quite a while, getting quite a bit of stuff back. and then made it down to the next one, and we wound up pulling it out in pieces. And it was kind of, at that moment, I mean, that was pretty early on in my career. It was like, okay, well, when we see this, immediately go to the stuck pipe log and get that in the hole, especially on a sand stuck situation, on a clean out, because there could, you might think you have 5,000 foot of stuck pipe, but in reality, it's probably just a couple 20-foot bridges, generally in a low spot of deviation across the lateral.
Yeah, that's absolutely true. And if you get an inkling that that they've had a blowout or some a substantial fluid movement downhole, you sure want to get that sonic pipe recovery log out, because there's no telling what's up, especially up in the annulus between the drill pipe and the casing, because in a blowout you can get all kinds of stuff blown up into the casing where you wouldn't expect it. You can get shale sloughing off from down in the open hole, and that gets blown up into the annulus between the drill pipe and the casing, and you got a stuck place there that you never would have expected. But using the sonic pipe recovery log, you can pick those all out.
Yeah.
Right.
I think both, a good pipe hand or a good pipe recovery specialist needs to know how to use both tools and know the importance of both tools and the kind of information that both tools can give you. I mean, probably 7 or 8 times out of 10, the free point tool is going to give you all the information you need. Maybe the sonic stuck pipe log ain't needed, or an RCBL, but it needs to be in your arsenal or your inventory out on location with you, so when you do run into these situations, you're already in it. You're already educated and know that you need to go in the hole with that and talk to the company man and the fishing hand, and don't sit there quiet, but voice your opinion and explain it, how these bridges can be a few feet above a collar, and as you're stretching the pipe, you ain't going to move it far enough to find these.
Yeah,
Right.
That's very true.
Yeah.
A good pipe recovery guy, he's at home with as at home with logging tools as he is with a string shot rod or a cutter. They're all tools that he uses to gather the information that he needs to make a good decision on where his pipe is stuck and what he's going to do about getting it free. The more information you have, the more accurate your decision making is. It's a lot better to make a decision based on knowledge than make a decision based on just guesswork.
What?
Okay. Hey, I was going to say, let me ask you why do you think so many companies are so reluctant to run the free point tools?
Well, I
think. Well, go ahead. Go ahead.
I think, and what I noticed through the years of doing pipe recovery, in my earlier years, and I'd say the first 2/3 of my career, when you got called out to a pipe recovery job, it was just a well-known fact. You're going to run a free point very first. It was unheard of to roll up on location and just go in and cut the pipe. Everybody wanted to go in and run a free point. That was just pipe recovery and fishing 101. You was going to show up and run a free point. And I think after the bust there around COVID, that 2017, 2018, I think there was a lot of people that wanted to know how to do pipe recovery but didn't have proper education on how to run a free point. And I think in the scenarios that we was just discussing, in particular of needing to know how to run a stuck pipe log and know that when you free point, find a stuck point, you cut the pipe and it's still not free, you need to go in with that sonic stuck pipe log and run a log and see where these bridges are. I think there was a lot of undereducated people in the field, and they didn't know how to set up and run the free point tool, or maybe they learned on a spring tool, and the company they're working for now, all they have is dog tools. if you've only run one or the other and don't have experience with both, it can be challenging on how to properly set the tool up. And I think what started happening is a lot of inaccurate free points started getting run, and a lot of unnecessary cuts and a lot of unnecessary fishing expenses started occurring. And from people not knowing how to suggest the right type of tool to find out where they was stuck. And I think people started going, well, if we're basically guessing already with these guys out here, we might as well just go in and guess without paying for that free point run. And they just started guessing, and I don't know, maybe they found a magic 8-ball they shake and say they can do it, find the stuck point that way with a magic 8-ball. But I think people started not appreciating the guys that were actually good and knew what they was doing and being able to find that stuck point and saving them money. And I think a lot of companies started gambling on guessing where their stuck point was and getting lucky. I think they started gambling and getting lucky, trying to cut corners. And, if you get it right 8 out of 10 times, well, look at all the money we saved on free points. But when you get it wrong, it can sure cost a lot of money. But I think a lot of it has to do with the education of the guys in the field, knowing how to properly run a free point and interpretate it the right way. And knowing how to do all the math that comes with it. In my opinion, a free point tool is one of the most easy logging tools to run. I think it's easier to run than a gamma ray. But the information that tool gives you and how you interpretate it to the guy sitting behind you is what separates someone just running the winch and running tools versus a true specialist, and being able to look at those needles and look at the BHA that's in the hole, look at the geographic location of the well and the tendencies in that region, and be able to turn around and lay out a roadmap of, okay, your BHA is here. You got these kind of tools. This is what you was doing. This is what happened when you got stuck. This is what I'm seeing. For stretch readings, I think we need to run a sonic stuck pipe log, because I think we could have other bridges running that, lay the two logs side by side and all the notes, and have a very constructive conversation with the EMP company and the fishing hand, and everybody voice their opinions. Something that I did on especially drilling rigs and workover rigs was I would show up on location and voice my opinion on we need to run a free point tool first, and depending on what they was doing, I'd throw in the sonic stuck pipe log. And I said, after we run that, we need to have a conference call with the superintendent or get everybody involved, and let's go over these notes together, and I'll brainstorm ideas so we can lay out a fishing plan for this well. And because the free point run and the sonic stuck pipe log, that's the roadmap to the fishing job. That's going to tell you all the information you need to know how to put this fish on the bank and not have to spend a ton of money in guesswork. And I think there was a lot of people come into the scene doing pipe recovery. A lot of guys, I think, started pumping guns because there was more money in it. And when it was busy, in the Bakken boom, and then in the boom that kicked off down in Texas, and I think that was about 2017, 2018, when things started going big down in Texas, a lot of guys started doing that, and a lot of pipe recovery guys that was really good started retiring, and they never passed on this kind of information. And I mean, that's one of the reasons we're doing this and calling it the playbook, is to pass on this knowledge and try and build a better pipe recovery specialist and get the trust back in the guys. I think a lot of it boils down to trust and guys being properly educated.
You're absolutely right. People are reluctant to run the free point tool because they've been bitten a number of times. I had people who claimed to be a pipe recovery specialist, and in fact didn't have the knowledge or the experience to give a correct reading. And you know, they spent a lot of money getting false free points, and
Mm-hmm.
at the end of the day, they didn't have any pipe laying on the ground, and you know that's a measure of success. Not whether you make a cut or not, but if you can pull pipe out of the ground and stack it up on the on the pipe rack, and
And
what we have to do is ensure that the people who are going into pipe recovery now have the technical training necessary to understand what they're doing, and then are given the opportunity to go out and get the experience that's going to be required to make them seasoned pipe recovery specialists.
well, and I
So
I
Yeah.
think there's a level of humility that has to come with this newer generation to get that trust back of if you do make a mistake or you are wrong, don't be scared to say it. You know, I've made mistakes
sure,
and walked over there and says, man, I think I was wrong. I think, you know, I got
sure,
this wrong. You know, and make it right with the company man or consultant that you're out for. Explain to them why you think you may have been wrong. A lot of guys will have a lot more respect for you for having the guts to walk over there and say, hey, I think I got this free point wrong. Or if you know, if you just free pointed a well and found it stuck point in their sand and you go perforate a hole and all of a sudden they decide they're going to circulate and then reverse circulate, well, they just changed the free point. You know, like go
yeah,
over there and you know, don't be scared to voice how that is bad for the well and why. You know, if they did something that could have changed the free point, uh, don't tell them you screwed up. You know, you screwed this free point up. We just wasted 4 hours running a free point for you to screw it up in 15 minutes. Don't tell them that. You ain't gonna get anywhere. I learned when I was in Texas. You know, you don't tell those boys that they're wrong, but you figure out a polite and professional way to explain to them. You know, we may have just changed that free point and explain to them why. And I think if you go about it with that attitude, I think you're going to start to see a shift of more free points being run, more stuck pipe logs being run, and a lot less money being spent on fishermen as a result because they're going to be making cuts and decisions based on knowledge, not guesswork.
yeah,
Okay. Yeah.
right.
All right. Yeah. So you mentioned, uh, you know, doing the pipe stretch and the calculations. Well, why don't y'all go over that where you talk about how you're getting ready to set up what you're going to pull, you know, what your neutral weight's going to be and all that.
Yeah. So when you show up on a job, a lot of people like to take a stretch reading when they first get there. And to take a stretch reading, you need to know what kind of pipe it is and what its weight is per foot, and know what the true vertical depth is or where the BHA is. And so you're going to take the depth times your pipe weight per foot. So just say that you got 9,800 feet of 2 7/8 in the hole. So you're going to take that 9,800 feet, times it by 6.5, and that's going to give you your neutral weight in air. And there's a few different theories and thoughts on accounting for buoyancy. If you're backing off pipe, you know, buoyancy is really important. If you're stretching pipe and free pointing, for your neutral weight running your free point, you need to know what your neutral weight is with buoyancy. So you want to look up what the buoyancy factor is for that weight of fluid that you're in. And correct me if I'm wrong. You take your buoyancy times your string weight, right? Yeah, that's right.
Yeah.
Yeah, that you.
Yeah, you apply the buoyancy factor to your string weight,
Yep.
and it gives you a reduced. You end up with a reduced weight because some of the weight of the pipe is supported by the
Yep.
the buoyancy of the, you know, and the buoyancy factor is just a comparison between the weight of 1 gallon of steel and 1 gallon of mud. You know, the formula is 65.5, which is the weight of 1 gallon of steel minus your mud weight divided by 65.5, and that gives you the that gives you the amount that that pipe is going to weigh in the mud. So,
Yeah,
um,
and once you come up with your neutral weight, adjusted to buoyancy, then to figure out your overpull weight, you're gonna take your pipe weight. So for 2 7/8, 6.5 pound, you would go 6.5 times 2208.5 times that pipe weight, and that's gonna equal how much you got to pull on that pipe to stretch it 3.5 inches per 1,000 feet. That's also the number you want to use when you're free pointing. So if you was free pointing, say you got a neutral weight of 68,000 pounds, 2208.5 times that. Let me hurry and look. 2208.5 times 6.5. So you're over pulling at about 15,000 pounds. So you would work it between 68,000 and about 82,000 is where you'd work the pipe. But
yeah,
to do a stretch reading, what you'd want to do is you would want to put the pipe at that 68,000 pounds for a neutral weight, go up and make a mark with some chalk or a crayon, some spray paint right at the top of the slips, a good definite mark. Stretch it that 14,000 pounds, 15,000 pounds to the 82,000 pounds, make another mark and measure that distance between the two marks, divide it by 3.5 and times it by 1,000, and that's your estimated stuck point. It's a good calculation to know, but it's also important to note that calculation is only good in the straight hole. As soon as you start getting any sort of deviation or dog leg or horizontal, that calculation for a stretch reading is irrelevant. We don't know how the pipe is reacting to the drag and pull laying on its side or a dog leg, or how much force it might take to come around that dog leg. So you really can't do an estimated stuck point if you got all that deviation and out in the horizontal. But if you remember 2208.5 times your pipe weight, that's one of the most important calculations in all of pipe recovery. And measuring your distance and dividing it by 3.5, that's two of the most important calculations, I think, in all of pipe recovery is knowing how to come up with that, because with that calculation, that lets you can figure just about everything else out in that well.
Mm-hmm.
Which speaking of how it only applies to vertical applications, an area that I see a lot of people get in trouble with and have issues is the minute they get deviation and go horizontal.
yeah,
I've seen other people really struggle with it. They can't find it free out past the 90 degrees or a few hundred feet past 90 degrees. And you got to start thinking out of the box the more unconventional that well gets. We start seeing, like in North Dakota, for instance, if a well's along the lake up here at 2,500 feet, they start kicking off about 25 to 30 degrees and slide under the lake before they go fully horizontal. So that calculation ain't really going to help you there with the deviation that you see. So something I did to find the free point was I'd figure, my buoyancy weight and what the neutral weight should be, and I would get in the hole with the free point tool and find where I started getting pipe to move, and I'd get to a good spot where it's 100% free. And what I would do is I would, before I went in the hole, I wanted to make sure that they had enough pipe on the rig floor that I could work that pipe into compression at least 10%. So if my string weight was 60,000, I wanted to be able to bring that pipe down to roughly about 40,000 at a minimum. I wanted to be able to bring that pipe down quite a bit. And I wanted to make sure I had enough room with my blocks and my top shiv that I could overpull that pipe quite a bit and not run into my top shiv. And when I would be in the hole with my free point tool and get it set up and I got some movement, I would over pull it, say to 90,000, and I'd have them come down. And as they're coming down on the pipe, my needle is going to move from 100 to 0. And the minute it hit 0, I would take my balance knob and I'd turn it back to 100. And they'd keep coming down, and I would turn it back. It'd go back to 0. And as soon as it would hit 0, I'd turn it back up to 100. And what I'm doing is I'm trying to find where neutral is on that pipe. When that needle quits coming down, and you'll see the needle bounce. Say the needle's coming down, and you get to about 55,000, and all of a sudden that needle bounces and then kind of quits moving on you. Well, now you just found out where that pipe stacked out and started compressing. There's your neutral weight. And then I would reset my needle to 0 and have them, come up to 90,000. And as they're coming up to 90,000, say I find that neutral spot at 55. Well, as they start picking up on the pipe, my needle don't start moving until say 60,000 or 63,000. Well, that's that curve and deviation factor that you're figuring out. At 63,000, when my needle started moving, that's where I started stretching the pipe. So my correct amount of overpull that I need to apply when free pointing needs to be based off of that 63,000, but I need to be able to get it back to neutral, so I'm going to have to come down to 55,000 when I work it. And being able to work it like that, and you'll see once you get in the horizontal, whenever I approached a horizontal to free point it, I would stop at kickoff point and take a reading, and I would write down, this is my neutral weight. I work the pipe between these weights. All right, kick on the pumps, and I'd pump down horizontal, and I'd go all the way to the end of the BHA. And I knew from doing it enough that it took roughly on 2 3/8 about 15,000 in compression and an additional 15,000 pounds of overpull to be able to work that pipe and see a free point out in the horizontal.
Sure.
And I would play with it with my balance knob. Once you get your sensitivity set, I would play with it with my balance knob and see I would see the differences in, call it the curve factor or
I know the first goes
or
right.
whatever it is.
Okay.
Call it the curve, however the curve affects it. But that's what it would take to see a free point out there. And I think a lot of people, when they would go and approach a horizontal, most pipe recovery manuals only cover vertical applications. A lot of these pipe recovery manuals haven't been written, anytime recently. So a lot of people's theories only worked in the vertical, and you had to get unconventional to find that stuck point out in the horizontal. And I think if you're willing to compress that pipe and work it, you'll start finding, rather than be stuck at 500 feet past 90 degrees, all of a sudden you're able to find it stuck 10,000 feet out across the horizontal.
Right.
Right.
Sure, because when your pipe is vertical or nearly vertical, you pull on it and you stretch it, and then when you relax the tension of the pipe goes back to its original length. But when you get out in the horizontal, you pull on the pipe and it stretches, but when you relax it, that there's not that weight to pull it back to its original length. In fact, the whole pipe is affected by the friction of since it's horizontal. So you can't allow it to assume its previous length. You actually have to push it back to its neutral length. It won't go back by itself because it's horizontal, and the weight of the pipe isn't acting to straighten it out. The weight of the pipe is acting to increase the friction.
Yeah.
So you have to actually push that back.
Yeah.
Right.
I always noticed if you come down and you only worked pipe, using the same old vertical applications and the same old pipe recovery calculations that are in all the manuals, you'd never find it more than 30 or 40% free. And then all of a sudden, well, come down an extra 10,000 pounds. All of a sudden your needle goes all the way back to zero, and okay, you pick up and come up an extra few thousand pounds. All of a sudden you got 100% movement, and you're able to get all this extra pipe out of the ground. That pipe, unless you push down on it when it's in the horizontal, it can't fully relax. It just like
Yeah,
you were saying,
right.
Bill. And I was on a job in West Texas, down there, and call came in, and they was stuck out there at about 18,000 feet in the lateral. Their kickoff point was about 8,500 feet. And I get out there, and, I'd spent a lot of time up here in North Dakota working on horizontal wells, and I get down there, and I get rigged up, and I go up on the rig floor, and I ask them, what's your weight? That the top of the pipe was right there at the top of the slips. I asked them what their weight was, and they was right at neutral. I think it was at 65,000. I said, well, you need to pick up a pup joint. I want to get this down all the way to, 35,000 with how far they was across the horizontal. And they looked at me all kind of cross-eyed, like, well, why do you want to push down on the pipe so much? And I said, well, we kind of need to. We're out in the horizontal, and the company man come up there, and he's like, no, he just, right. I was, man, just trust me. We need to push down on the pipe, and to be able to see this free point. And he's like, well, we've never been able to see a free point much past night. We always get stuck in the hill. We can never, for some reason, we get stuck in the hill on all of our wells. And I just, all right, well, I want to pump it all the way out to the end and anyway, and kind of see what I come up with. And they picked up some pup joints and, appeased me, and I got in the well, and I pumped down all the way out to the BHA. I checked at kickoff point, and the pipe was free at kickoff point, and I started pumping down, and I got around the curve, and he asked me, well, aren't you going to stop and check here? And no, I'm going, once I start pumping down, I go all the way to the end. I don't like pumping and stopping, and it's a pain in the butt with a free point tool to kick the pumps on and off. So I pumped all the way down to the BHA, and I pumped all the way out there to the end and started taking readings, and I was working the pipe quite a bit in compression, and I found it stuck about 500 feet off the BHA, and
Yeah.
and he looked at me, and he's like, that can't be right. I was, well, the pipe's moving. Like, I don't know what to tell you. You're stuck just barely right above your bit. You only got a handful of joints that are stuck. I told him, the pipe's moving out there. We can cut it right here. You don't have a very big fishing job ahead of you. And he wanted me to come up, pull, and check another 1,000 feet. Well, if the pipe's moving all the way out at 18,000 feet, the pipe's going to move at 17,000 feet and 16,000 feet. We checked every 1,000 feet the whole way out of the hole. And when my manager showed up, the first thing he did was take a stretch reading. And, he was a pretty good pipe hand, and he takes a stretch reading, and he's like, well, it's stuck right there at about 88 degrees, 90 degrees. It's, not much further past kickoff point. It's right there. And I said, well, that only applies to the vertical. That doesn't, we got 10,000 foot of pipe out here to the side that we're trying to look at too. How do you account for that? And he sat and tried to explain it to me, and I was like, well, explain this to me. Why am I seeing stretch out all the way out at 18,000 feet? And he says, well, you're working the pipe too hard. And I said, well, when you're pulling out of the hole with wire line on a long lateral, does your string weight weigh what it would in the vertical? well, no, you're pulling a little harder. You got to pull it across the horizontal. And I said, exactly. When you're stretching pipe across the horizontal, you got to work it a little harder. And if you have all this tension on the pipe, you got to relax it to get it back to neutral. So you got to push down on it. And we went back and forth on this idea in theory. And then finally the superintendent for that company said, you know what? Why don't we just cut it out there where he said it's free and see what happens? And I kind of chuckled. All right. I knew what was going to happen. I cut it. The pipe jumps. They tripped out of the hole. They were back to cleaning out in, a matter of 24 hours. And my manager come over and he's like, I've never seen that done before. And I said, well, unless you've done a lot of horizontal work, a long ways away sideways, I guess you wouldn't know. You wouldn't know. You wouldn't know any better.
Sure.
And they wound up, they had two workover rigs side by side, and the other one wound up getting stuck about 13 hours later. And I stayed pretty busy out there for a while, but they had never seen that before, seen someone push on the pipe like that and use compression for helping finding a free point. And I think that's very important and for people to understand. And, you don't have to stay between the lines. I mean, they call it unconventional drilling and wells for a reason. You can be a little unconventional to find where you can get that pipe out.
Yeah.
Absolutely. I don't think a lot of people realize you can do that, and that's okay. But that's kind of the difference in the horizontal versus the vertical. The vertical, all the math lines up. It works. It's pretty simple. But as soon as you start getting deviated and moving sideways, you got to start thinking outside the box.
Yeah.
And then that brings up another question. There's lots of different free point tools out there.
Sure.
I mean,
lots of ways of anchoring it and lots of ways of measuring it.
Yeah, I mean, what was some of the early free point tools that you used, Bill?
Well, I went to work for McCullough, and it was in 1977. And at that time, they'd come up with a brand new free point tool. It was called the Magnetector, and it had two electromagnets, one above and one below the sensor section, and it was a slick tool. And you'd run it in the hole, and then you'd energize these magnets, and they would stick to the pipe, and that would keep the free point tool from moving. Then you'd stretch the pipe, and it would detect a stretch. It really wouldn't detect torque, but it did detect stretch. And we also had some tools which used spring type anchors.
Yeah.
And
I think the two biggest types of tools out there today is the motorized, like the Titan Dog tool, and then Advance's spring tool, or the Advance's spring tool with the slack joint and spring section. I think those are the two main types of free point tools, at least that we see domestically here in the United States. And they both have, their areas they shine, and they have their areas where probably the other tool's the better option.
Yeah.
I think in when it comes to horizontal work, I think the Titan Dog tool's superior. It's short, it's small, it doesn't have a slack joint, it's two motor sections and a sensor. It's easy to pump down, and you don't have to reset anything to take readings. You can keep coming up hole and keep getting readings. You just have to remember to slack off. I see a lot of guys, their first time running a motorized tool, they forget to slack off, and they wind up breaking the shear pins in the tool. And spring tools or magnet tools, I think their area they shine is if you got to go through a spear or a
Sure. A restriction.
yeah,
Yeah.
they
or just small pipe,
yeah that
or just small.
you get smaller than 2 3/8. The inch and a half dog tool don't fit. You have to a good pipe pan has to know how to use both the magnet spring version and also the motorized version. I know I've done a lot of pipe jobs backing off casing where they would have a spear in the well with a 1 1/4 ID, so I'd have to run a 1-inch free point tool with magnets and go down through there and take free point readings with that, and that worked great. And I've worked on a lot of 1/9 pipe and 1.5-inch coil using Advance's tiny little tools. But if you got a drilling rig with non-magnetic pipe, that spring tool and magnets have a heck of a time trying to work in that.
Yeah, that's exactly
Yeah.
right.
You know, that's an area where the dog tool really shines.
Well,
Right.
and the dog tool, well, yeah, with the spring with the Bowspring tools, you also get to measure torque in addition to stretch.
Yeah,
But when you put magnets on the permanent magnets on the Bowspring type tools, you can't measure torque with those. You just measure stretch.
yeah. Knowing how to take a torque reading and but I mean, Bill, would you if you was going into on a drilling rig, do you use stretch and torque to find a free point?
Oh, absolutely, absolutely. I think torque is very, very valuable. You know, if especially if you're going to do a back off.
Yeah.
If you know you take a stretch rating, and sure you can get the you can get stretch down hole, but if you can't get your torque down hole, you're not going to back it off. You know
Yeah,
that's you won't back it off if you can't put that tool joint if you can't torque up that tool joint. So yeah.
Whenever I was going
Uh,
to do a back off, I would take stretch readings until I found where I wanted to back it off, and then I would take a torque reading at that collar.
Yeah. Right.
Just because it always seemed like it was a race to the bottom of the hole, and I knew I was in for a long haul out there, so I'd take stretch readings so I could find where it was free, and then once I found where it was free, and it's okay, we want to back it off there. Okay, well let me take a torque reading real quick, make sure we're good. And that's when I'd apply the torque readings with the dog tool or even the spring tool.
Right.
You know, another thing I think people get bad free points or inaccurate free points is when they got a mixed string in the hole.
Yeah.
Yeah, that's
Sure.
true.
Sure. Because you have the different weights of pipe stretch different amounts under the same amount of tension.
Yeah.
So you got.
I think the most common mixed string is on a drilling rig where you got regular drill pipe, and then you might have, say, 10 stands of heavyweight drill pipe, and then there might be one stand or 4 or 5 joints of Mon-Els that are even heavier.
Sure.
And I think people get free pointing, and they figure out their weights and what to work the pipe to find your free point based on the drill pipe that's in the hole, and then they go into a heavier pipe that requires more overpull to see that free point. And on a workover rig with a fishing string and drill collars, that workover rig may not have enough crown capacity, or the pipe above it may not have enough yield strength to be able to pull it hard enough to see an actual good free point in that heavier pipe.
Yeah.
Generally, most drilling rigs have enough power and capacity that they can pick up on it and pull it hard enough to at least see 60 to 80% free movement and some heavy weight. Mon-Els generally if you can see 30% movement in a Mon-El joint, boy, that's pretty good. That's probably free pipe.
That's free. Yeah, that's free pipe.
That stuff's. I had a guy one time. I was on a drilling rig job, and we'd already backed them off up higher, and they were stuck at the bit. And I originally told him, we could go back it off on top of that filter sub, and wash over that one joint of Mon-El, the motor and the bit, and this thing will be out by breakfast. And he's, no, let's back it off higher. And I said, okay. We backed it off higher. They went in with jars, and they wore the jars out. And he's like, well, I guess we'll back it off there. And then I was like, man, we could back it off right on top of that filter sub in the middle of the Mon-Els. And well, let's go in with a free point tool, make sure we're free there. They wasn't quite convinced that they was free all the way down there. And I was only seeing about 20-30% movement, and he's like, well, we're still stuck. And I said, well, not necessarily. I said, we'll part this drill string before we stretch that Mon-El 100%. I said, that stuff's not meant to stretch. I said, it's like 60 some pounds a foot. It's some heavy pipe. And I said, we're able to see 30%. And I said, that's pretty good. And I told him, I said, I'm actually quite confident that this is 100% free and we could back it off on that filter sub. And well, I don't know. And I said, well, where would you, pretend those ain't Mon-Els. I said, where would you like it backed off? And he said, well, I'd like it backed off where you're saying, but I just don't think that can happen. And I said, well, it's got threads in it. I'm able to get my shot rod about 3 feet into that joint before we stack out on top of the filter. I said, I'll go back it off right there if you're okay with it. And he said, well, I'm just not quite so sure it's free, and I'm not so sure you can back that off. And we went in there and unscrewed it. And he said, go ahead and add about 15% to that ticket. He was quite impressed. So always keep that in mind when you have a mixed string. If you're taking readings in the normal tubing that's the majority of the string, and you're seeing stretch, and then you drop into a heavier pipe, and all of a sudden you go from 100% free on your free point down to maybe 40 or 50% free, we'll figure out how much you got to stretch that particular type of pipe. If you're going from a 5-inch regular drill pipe to a 5.5 heavyweight drill pipe, that might be a 20,000 pound difference in how much you got to stretch that pipe. So the type of pipe that you're in when you're taking your reading, you need to make sure that you're stretching it that proper amount to stretch it the 3.5 inches per 1,000 feet in order to see that stretch. But you also got to be mindful that you don't pull it too hard that you part your upper string, or it becomes a safety concern where you could crater the rig over. So you got to pay attention to that and look at the BHA diagram and the pipe tally of what's in the hole and what the weights are down there of each type of pipe. And when you're taking your free point, that you're accounting for those changes and differences, especially on a drilling rig where you got Mon-El, you got heavyweight, you got drill collars, you got drilling jars down there, you got regular drill pipe. I mean, they got so much different stuff they run nowadays that make our job way more complicated, that you got to account for all the different kinds of pipe. And otherwise you might confuse yourself, or you might confuse the company, man. And when you do get in that other kind of pipe, explain it to them. We're only seeing 40% movement because we're not able to stretch it enough. But we're seeing 40%, and if your needle's moving, the minute the pipe starts moving, the needle starts moving. Well, you're probably in free pipe.
Right.
Just calculate your overpull for each string of pipe. Your 4.5 1660, your overpull is going to be about 37,000 pounds to give you 3 inches of stretch, or 1,000 feet for every 3.5 inches of stretch. But if you have 60 pound per foot drill collars, you're going to need about 133,000 pounds to give to get 3.5 inches of stretch per 1,000 feet.
Yeah.
So
Right.
it's a tremendous change.
Yeah. The you know, one that can definitely throw a wrench into the system is going to coil tubing. And
Oh, yeah.
free
Oh, yeah.
free
Yeah.
point and coil tubing. That one can you know, unless you've worked on it or had someone that has worked on it explain it to you, you know, coil tubing can really and I think the most important thing to coil is how you set the job up in the beginning, before they disconnect the coil.
Yeah.
A lot of coil companies or the EMP company, they ain't gonna know if they're out in the horizontal stuck with this coil, and they're gonna call you in to wireline it on top of the coil unit and they're gonna kill the well and disconnect it at the top of the injector head of the coil unit. The most important thing is put that thing 20,000 pounds in compression and figure the weights. They're gonna a coil unit's gonna give you what their neutral weight is when they was milling and doing stuff. Well, they got nitrogen in the hole. The string's lighter. The weights that
Right.
that they give you are gonna be a lot lighter than what they really are. And as you get pumping down and doing things in that well, those weights are gonna start to change.
Yeah.
The
That's for
the
sure.
biggest thing with coil is when a coil unit calls you, before they disconnect that pipe and you show up, have them put that thing in compression. Get the coil in compression.
Mm-hmm.
They can pull it. You got all the room in the world out the top of it once it's disconnected. You know, as long as you
Right.
bring a big enough crane, you
Right.
you got all the room in the world to go the other direction. But once you cut that coil off, you can only go so far down. You can't add any more. And
That's right. That is very
and
true.
Yeah, that's true.
if you set the job up like that, then it becomes just a routine job inside pipe.
Yeah.
Other than when you're free pointing,
Yeah.
who's ever running the crane, you want to make sure you got a guy that's out there running the crane, holding your lubricator in the air, because that thing's going to be going up and down. And
Yeah.
you know, you want to make sure people are paying attention when you're working on coil. There's a lot of moving parts.
A lot of moving parts.
And
And very small and delicate tools usually.
yeah, it's you know, my lead operator, Doug, that I had for years, he'd always go out there on the rig floor with the rig operator while I was free pointing, and if he come down, he'd always instruct them, you know, while we're free pointing, you know, this tool's cost more than what you make in a year. You come down and break that tool, that engineer's going to be pretty hot. And and he would explain to him, you know, the slower and smoother you are with that rig, the better readings and the quicker this is going to go. But if you come down too quick and you're slapping it around, you're upset or whatever running the rig, it's going to make it so he has a harder time taking readings, and you could break our tool, and our tools cost quite a bit of money. And he would sit up there and explain to him, and he was really good at that. You know, another, I think, important thing when free pointing is having a good operator that you've instructed how to manage the rig operator up there and communicate what we need with the rig operator to make sure, you know, your tools don't get broke down whole, and you get good pulls and good compression when you're trying to take your free point.
Right.
Right.
That's very true.
Which you know, I mean, the tension and compression, you got to have both, I think, in my opinion, in the well.
Got to have both.
In the wells today, and how smooth that rig operates. You know, have them get it in first gear or low gear, so everything's just moving nice and consistent and slow, and you'll get really good, accurate readings, and make your job a lot easier.
Yep.
Yeah.
I mean, what's a way someone you know, say a job calls in, they got some stuck pipe and they just come out here and cut my pipe free, you know, and you know by the geography of it and what they was doing, they're probably not stuck where they think they're stuck. Hey, how's the way
Right.
how's the way someone could sell the free point run to someone that's against it the minute they call you?
Well, I think most people will if you explain to them you're going to make some very expensive decisions, and we want to make the decisions based on knowledge, based on knowledge, downhole knowledge, you know, which we can only gain by using our free point tool, because you know, we ran over our drill pipe goggles on the way out to the job, and we can't use them to see where it's stuck anymore. So we have to use the tool, and we make a decision based on knowledge rather than just on a shot in the dark.
Yeah.
Let's get this over with. Let's make one run and get this pipe out of the hole. Let's not make 3 or 4. You know, start deep and shoot string shots and jet cutters as we're moving up the hole. You know, that's a very expensive way to spend some time. So I think a logical explanation to it like that is probably the best. Some people you're just not going to convince, and they say, you know, this is where we're stuck, and this is where I want you to back it off. You know,
I always worded it that, well, you know, just come out here and cut it. All right, and I wouldn't try and convince them or sell them over the phone. I might talk to them a little bit about it, very briefly. But okay, you know, just tell me where you're at and what kind of pipe you are. And I had my enclosed trailer full of tools, my rolling wireline shop, and I had the free point tools with me. And I would get out there on location and go in the shack and listen to them at what they had going. And it's like, man, are you sure you don't want to run a free point? Because we're going to be going in the hole of the cutter, and these cutters ain't cheap. And if you cut it and it's still stuck, then, you know, you could make this a lot worse. It's going to be a lot more money. I said, you know, the free point run's actually probably one of the most cheapest runs that we do, but provides the most knowledge that can save you the most amount of money. So you run it, you spend an extra, you know, 3, 4, 5 grand, whatever you charge. Well, you always make your cutters cost more than the free point run. So, you know, you got to run 2, 3 cutters runs. It would have paid just to do that free point. And I would tell guys, you know, why not measure once and cut one, or take a good measurement and make a cut based on knowledge, and rather than let's just go to hacking. You know, you don't build a house just starting cutting boards and throwing them together. You break out your tape measure and you look at the drawing. You know, everything else you get a road map or a basis to go off of. Cutting pipe should be no different. You know, the free point tool and a stuck pipe log, that's your road map and your blueprint at how to fix that well, and explain it to the company man and the consultant that way. You know, we kind of need this to know what we're doing down there. You might have a bridge up higher that we ain't gonna see it till we get in the hole of the logging tool and find it. We ain't gonna get lucky. They might get lucky a handful of times, but when they don't get lucky, I mean, it's good to be in the wireline business and selling them cut runs that cost more. You know, we make a lot more money, but they sure do get upset about it.
Yeah, right. Yeah, and their boss's boss is going to be upset about it.
Yeah,
too,
and you know, in an area that you'll, I think that you'll find, if you don't try and push them too hard on the phone, you know, yep, we'll get on the road, sir. We'll get headed that way. And you get out there and you go in the shack and talk to them and you explain to them how important that free point run is. Well, then you're gonna see the look of fear in their eyes. Oh God, please tell me you brought it. Well, yeah. I
Yeah.
brought
Right.
everything. Yeah, you know what? Let me make a phone call, and while you're rigging up, he's going to come out, and I bet 9 out of 10 times, you know what? Let's run that 3-point tool first. I thought about it. I made a phone
Yeah.
call. You're right. Let's run that 3-point tool. I think 9 out of 10 times, if you're able to explain it to them on why it's so important, I think you'll find a lot of the times they'll come back and, you know what, that little bit of extra money's worth the investment. And
Sure.
if you know wholeheartedly deep down this has got to be stuck in a different spot, you know, yeah, I used to always bet guys, well, I'll tell you what, you know, I'll make you a bet. If it's stuck where you say it is, you know, then I guess I'm not going to charge you for it. But if it's stuck where I say it is, you know, then you're going to pay full price and you'll thank me later because I just saved you a few extra cuts.
Yeah.
And, you know, you get some guys that like to make bets and gamble with it like that. And, you know, very rarely, I think maybe 1 or 2 times over 15 some years, I had to give a 3-point away for free.
Right.
You
Yeah.
You know, it comes back to how you present yourself and how you talk to the company man and how you present the 3-point run to him and how you build value. You know, it's part of being a good sales guy out there too on location, right?
Yeah.
It's how you present
Right.
the idea and build value in the idea so they can see the value in it of making that
Right.
run.
Right.
Absolutely correct. Absolutely
You
correct.
know, if you can build the value in it and then go in there and find it stuck in a place that they didn't think it was, or maybe it was, you know, but now you can paint them a picture and draw them a good roadmap of, okay, well, you're stuck here. You know, we can go make a cut here and, you know, they can start making phone calls. And I think a lot of the times you'll find it's stuck in a different place than where they thought. And they're going to be awful grateful to you. And you just moved up the call list in their book. This guy just saved
Yeah.
us a boatload
Right.
of money.
Right.
Exactly.
When you find a free point, you know, what percentage of free pipe should someone have before they make a cut?
Oh, I think you know I don't think you can put a number on a single number on that. You know, like we talk about drill collars, you see 20-30%. Heavyweight drill pipe, maybe 40%. Those indicate free. Drill pipe, tubing, it depends on the your 3-point tool and your panel and your experience with that tool.
I think
You know, you
you definitely want to make a cut and definitely a back off in good free pipe. You know, not 60s.
Yeah.
If you got a feeling that, or if your 3-point tool, like in tubing or casing, if you're only showing about, you know, 50, 60% free, you should probably come up higher and find where it's 100% free and then work your way back down where you start seeing that shift. Because that could be some fill, you know, that's where the stuck pipe log's going to come in handy.
Yeah.
And show you, well, yeah, we, you know,
Sure.
there's our solid stuck point, but we kind of getting, you know, a bit of change here over 150 feet, and that's the top of your fill, you know. So making a cut, you probably want to make sure you're in 100% free pipe, because what can happen is once you cut that pipe, they might be able to pull it out, but it also might slough in and a lot of junk fill inside that pipe, and if you're in the horizontal, that could keep you from pumping down.
Right.
You know, so
Right.
I always tried to suggest, you know, 100% free pipe, find where that hard line is of free from stuck, and come up a joint and a half. You know, a good joint and a half.
Yeah.
Right.
Yeah, I think
Good joint
Yeah.
and a half gives you plenty of room.
gives you plenty of room.
Yep.
That's right.
I mean, what's kind of your
Yep.
final thoughts, Emery, on free pointing and stuck pipe logs?
Just that, yeah, it's most of the time it's really critical, and it's really in their best interest to run one, because otherwise, like you said, you're just making blind stabs at where it's actually free. So,
Yeah.
Yeah, if you don't know where you're stuck, there's no way you're going to get free. You got to know where you're stuck. You got to know what the situation is in order to make a correct decision.
Yeah.
Either that or just be really, really, really lucky.
Yeah. Yeah. I mean, if you can go in and guess every time and get lucky, you know, I guess you can sure whisper to the pipe. I mean, what's what's kind of your final thoughts on it, Bill?
No, my opinion has always been that free point is the most important single piece of information that you have going out on the well. That and the better, the more accurately you can determine your free point, the easier your job's going to be. The more efficient your time is going to be spent on the well. You know, the goal is to go out there and back off the pipe or cut the pipe and pull that pipe out of the ground and lay it on and lay it on the pipe rack. And you want to do that as quickly as you can, because once you've done that, you can go home.
Yeah.
Yep.
No, absolutely. I agree with both of you. You know, that a free point and stuck pipe log is the single most important tool you can have. It's what separates you from a shooter or a gun runner or a winch jockey from being a pipe recovery specialist. You know, can you run the free point and the stuck pipe log and be an engineer and interpretate the data that it's given you and help paint the picture and draw the roadmap for the E&P company and the fishing hand to lay out the fishing job. You know, without these two tools and these runs in the well, you can't do that. And, you know, being a good salesman and being able to get people to run this so you can draw a good picture for them at what's going on down there. It's the single most important step that you can do. And I definitely think in today's industry, people need to get back to that's just the standard in pipe recovery. That's the first run made on every job is we need to go know where we're stuck, and then we're going to start coming up with a game plan.
Yep.
But that kind of wraps it up on free pointing and free pointing 101. We hope you guys enjoyed it. If you have questions, shoot us an email. You can email us at support@mcroiltools.com, or you can like and subscribe to the channel and leave us a comment on the podcast, and we can answer it. We can answer it right here on the podcast, or we can email you. You can also reach out and call us if you're ever in a bind. You know, reach out to us at our support email. Me, Emery, and Bill, I'll get the email.
Sure.
We all see the comments that you guys might leave. But thank you everyone for listening to this. We really enjoyed it, and we hope this really provides a lot of insight out there to free points and stuck pipe logs, and reiterate on how important they are in pipe recovery. You know it.
Yep.
But be sure to check out our website at mcroiltools.com, or look us up on LinkedIn. We're pretty active on LinkedIn. We post stuff on there weekly. You know, the stuff we might be coming out with and things we're doing. You know, some of our licensees, when we see good cuts, you know, we post them there on LinkedIn. You know, you can hop on over to the YouTube. Get on YouTube. We got a lot of videos getting put on there. Videos about the torch, videos about pipe recovery, videos about our stable lock. You know, hop on over to YouTube and check it out. If you're listening, be sure to subscribe to our channel, the Pipe Recovery Playbook. and share it with your fellow pipe recovery guys. We appreciate everyone listening. We hope everyone enjoys it as much as we enjoy it. we have quite a bit of fun doing it, I think.
Right.
Right.
Yeah. Yeah.
So-
Thank you for your attention. We
Yeah,
greatly
thanks for the
appreciate it.
time, and we'll see you you
Yeah.
next time.
So leave a comment or shoot us an email at the support, and we'll discuss it right here on the playbook. Thanks again for tuning in, and we'll talk to you guys next time. Be safe out there.
Okie doke.